So in this lesson, we are going to look at the application of numerical cases, that is in binomial expansion. In our previous lesson, we have learned about the Pascal triangle and how it helps us to expand the binomials. So in this lesson, we learn how the binomial expansion helps us to solve numerical problems. For example, if you are given 0.98 to power, let's say 5, without using a calculator, it will take you some time to be able to compute. But using the binomial expansion and application of the Pascal triangle, then we can be able to solve this problem in a very easier way. So we are going to do that by use of example. So I'll solve for you 1 or 2 examples. Then you can see how we apply the binomial expansion to solve numerical problems. In this example, we are going to use binomial expansion to evaluate 0.98 to power 4 to 4 significant figures. So before we expand, let's write 0.98 raised to power 4 is equals to, it is the same as 1 minus 0.02 into bracket to power 4. So note here we have not changed, because when you subtract 1 minus 0.02, you still get 0.98. So we are writing it in this form. So we can now use binomial expansion to help us solve this. So this is equals to, we now expand. We use 1 as the first term and 0.02 as the other term or variable, as we said. But in this case, we are dealing with real numbers. So we write the coefficient are 1, 4, 6, 4, and 1. So we write 1 is raised to power 4. When the sign is negative, we alternate, so we have minus. The next coefficient is 4. Multiplied by 1 to power 3, it reduces the power by 1, and we multiply by 0.02. Then we write plus, we have 6. We have multiplied by 1 to power 2, multiplied by 0.02 into bracket squared. Then we put minus. We have 4 multiplied by 1 multiplied by 0.02 into bracket squared minus. We have 0, this is plus 0.02 to power 4. So from there, so this is cubed. From there we can work it out. We write this will give us 1 to power 4 is the same as 1. So we have this equals to 1 minus, here we have 4, multiplied by 1 is 4, multiplied by 0.02, we get 0.08. Then we have plus 0.02 squared multiplied by 1 squared remains the same, multiplied by 6, we will get 0.0024. Then we have minus 4 multiplied by 1 is 4. You multiply by 0.02 cubed, you will be able to get you use your calculator to compute that, 0.0032 plus. Now we have this 0.02 to power 4 using a calculator, you get 0.000016. So that is the expansion. When you compute, you get it equals to, using a calculator, 0.9224 no 23 6816. Now, because we are told to work with 4 significant figures, then this is equals 4 significant figures. You get it is equals to, this is 1 2 3 4, the next one is 6, so we round off, so we get it is 0.9224. so those are 4 significant figures. So that is the expansion of this number, that is 0.98 to power 4. When you expand, you get that, you get 0.9224. So that is how we apply the binomial expansion to solve numerical cases. 23 then 28, but remember we are told to 3 decimal places, so we count 1 2 3, the next number is less than 5, so our final is 137.233 to 3 decimal places. So that is how we work out that problem. So you have seen how we make use of the binomial expansion or the Pascal triangle to be able to solve numerical problems. In our example 3, we are told to use Pascal triangle to expand 2 minus x over power 5 up to x cubed. Use your expansion to estimate 1.5 to power 5 up to 3 decimal places. Now we start by expanding our 2 minus x. So we say 2 minus x into bracket power 5 is equals to, okay, we start with 2 to power 5, then the next is minus, the next coefficient is 5, so 2 to power 4 multiplied by x plus the next coefficient is 10, 2 to power 3 and x squared, then we have minus 10 to power 10, 2 to power 2, then multiplied by x cubed. So we are told to go up to x cubed, so you stop there, but you can continue, but the condition given you have to satisfy. So when you open, when you expand, you get 2 to power 5 is the same as 32 minus 2 to power 4 is 16 multiplied by 5, you get 80 multiplied by x plus 2 cubed is 8 multiplied by 10, you get 80 x squared minus 2 squared is 4 times 10 is 40 x cubed. So you stop there. Now we come to 1.5 to power 5. You say 1.5 to power 5, we get 1.5 to power 5 is the same as 2 minus 0.5 into bracket to power 5. So in this case, we substitute the place of x with 0.5 because it will take the place of x. So we say this is equals to 32 minus 80 multiplied by 0.5 into bracket plus 80 multiplied by 0.5 into bracket squared minus 40 multiplied by 0.5 into bracket cubed plus. So this is equals to 32 minus 0.5 times 80, it will give us 40. Then we have plus 0.5 squared multiplied by 80, you get 20. Then we have minus 0.5 cubed multiplied by 40, you get 5. So when you compute this, you get 32 minus 40 is minus 8. Minus 8 plus 20, we get 12. 12 minus 5, we get 7. So the expansion of this 1.5, when we consider x cubed, is 7. So our example 4, this is a question that I came across in one of the past papers. So we are supposed to simplify this expression. So I'll start by expanding the first one. So I'll say 2x plus 1 over x raised to power 4 is equals to 2x raised to power 4 plus 2x raised to power 3 multiplied by 1 over x plus 6 2x into bracket squared. Then we have 1 over x squared, then plus 4 multiplied by 2x, then we multiply by 1 over x into bracket to power 3, then we add to 1 over x into bracket to power 4. So when you expand that, you'll be able to get this is equals to 2 to power 4 is 16. So we have 16x to power 4 plus 2 cubed is 8. 8 times 4 is 32. So in the denominator we have 1x. In the numerator we have 3x. So we will be left with x squared plus 2 squared is 4. 4 times 6 is 24. So here we have 1 over x squared. So the denominator x is squared and the numerator x is squared. So they will cancel. So plus, this is 4 times 2. This is 8. In the denominator we have x cubed. Numerator we have x. So we will be left with x squared in the denominator. Then plus 1 over x to power 4. So that is the expansion of the first part of our equation. We come to the second one. The difference between the first one and the second one is a minus sign. So expansion of the other one will be 2x plus, not plus, but minus 1 over x into bracket to power 4. So this is equals to, so we only interchange the sign. So this will give us 16x to power 4. Now here we have minus 32x squared. Then we have plus 24. Then we have minus 8 divided by x squared plus 1 over x to power 4. From there, we are supposed to add the 2. So if you add this one, the upper one and the lower one, you can see we have 16x power 4, 16x to power 4. So this will give us 32x to power 4. Then the next one, we have 32x squared, 32x squared minus. So this will go with that one. Here we have 24 and 24 here. So we will have plus 48. Then we have minus 8 over x squared and plus 8 over x squared. So this goes with that one. Then we have 1 over x to power 4 plus 1 over x to power 4. So that will give us plus 1, that is 2 over x to power 4. So that is the expansion of that. So you get 1 mark here. So you get one mark here, another mark here, and the mark for the answer. So that is how you answer such kind of a question.